everybody! Mohini here, back with another super helpful video. Aaj hum baat karenge some important concepts of physics, kinetics, work, power, energy, basically everything you need to ace your next exam. Don't worry, we'll break it down in a way that's easy to understand. Remember guys, you surf important topics high, exam ke liye pura subject detail me padho. This video is just to give you a quick guide and help you remember the concepts quickly and easily. So if you're ready to conquer these concepts, hit that like button, subscribe to my channel, and let's get started. D'Alembert's principle. Sounds scary, right? But trust me, it's not that complicated. It's basically a way to solve problems related to motion. Imagine you're pushing a heavy box. You're applying force, right? But the box is not moving as quickly as you'd expect. Why? Because there's an opposing force acting on it. Friction. D'Alembert's principle says that the sum of all forces acting on a body, including inertial forces, is equal to zero. Inertia MATLAB. The tendency of an object to resist any change in its motion. So in our example, the force you're applying, minus the force of friction, equals zero. Basically, we're treating the opposing force as an imaginary force called the inertial force. This principle helps us analyze the motion of objects even when multiple forces are acting on them. It's like a shortcut to solve complex problems. Remember, jab bhi forces are motion ki baat ho. D'Alembert's principle yaad rakhna. It might sound complicated, but once you understand the concept, it'll be your best friend in physics. The work-energy theorem is like that friend who always connects the dots. It basically tells us that the work done on an object is equal to the change in its kinetic energy. So if you apply a force on an object and it moves a certain distance, you're doing work, right? And what happens to the object? Its speed changes, meaning its kinetic energy changes. This theorem simply states that the work done is equal to this change in kinetic energy. It's like a before and after picture of energy. The work done is the difference between the two. This theorem helps us understand how much work is required to achieve a certain change in an object's motion. It's a fundamental concept in physics that explains everything from a ball rolling down a hill to a rocket launching into space. So, next time you see something moving, remember the work-energy theorem. It's the silent hero connecting work and energy. Chapter 3. Conservation of momentum and energy. These two principles are like the guardians of the universe, ensuring that everything stays in balance. The law of conservation of momentum states that the total momentum of a system remains constant in the absence of external forces. It's like when you play pool, the momentum of the cue ball is transferred to the other balls, but the total momentum remains the same. Similarly, the law of conservation of energy states that energy cannot be created or destroyed, only transformed from one form to another. It's like when you burn wood. The chemical energy stored in the wood is converted into heat and light energy. These two principles are interconnected and govern everything around us. They help us understand how energy and momentum flow in various systems, from the smallest atom to the largest galaxy. So next time you see a game of pool or a bonfire, remember the conservation laws. They're the invisible forces maintaining order in the universe. Chapter 4. The impulse-momentum principle is all about understanding the relationship between force, time, and momentum. It states that the impulse acting on an object is equal to the change in its momentum. Impulse is basically the force acting over a period of time. So a small force acting for a long time can have the same impulse as a large force acting for a short time. Imagine hitting a golf ball. The longer the club is in contact with the ball, the greater the impulse, and hence, the greater the change in momentum, resulting in a longer shot. This principle is particularly useful in analyzing collisions, where forces are often very large and act for very short durations. It helps us understand the impact of these forces and how they affect the motion of objects. So next time you see a collision, whether it's in a game of cricket or a car crash, remember the impulse-momentum principle. It reveals the hidden connection between force, time, and momentum. And that's a wrap on our quick guide to kinetics, work, power, energy. Hopefully, you now have a better understanding of these important concepts. Remember, these were just the basics, so make sure you study the complete syllabus for your exams. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe to my channel for more awesome content. Until next time, keep those brains buzzing.